Now the next one, I talk about how to draw, how to graph the sine cosine inverse of sine cosine tangent, and how to graph the combination between the trig function with the algebraic function. So you have to draw to scale in this case. Okay, you need to draw to scale. At least sine cosine you have to draw to scale. Okay, so now I'll show you why. So now to scale means pi is about 3, okay? You don't need to really accurate your 3 point something, just about 3. Pi over 2 is about 1.5, right? So therefore, if I choose the y here is 1 here. So this one, I count 1, 2 is 1, this and 1.5, so this one about 1.5, I put pi over 2, okay? So then I put 1, 2, 3, I put negative pi over 2. And so on different parts. So the graph of sine look like this, from here to here, and from here to here, and from here to here, and so on, right? But we know that restriction is like this, right? So then you mark here is pi over 2 and 1. And this one here I mark negative pi over 2 and negative 1. Clearly this one is an odd function, right? See? Now how to graph the inverse? So again I change, right? We change between x and y. Now x become 1, y become x become 1, x go 1 here. Pi over 2 is right here, pi over 2 right here. So the point right here is the inverse of that point. Okay. So now if you draw the line of reflection, you see more clear. If you don't graph to scale, your line you jump over. Okay. These are not really. Actually, this one have to be moved a little bit beyond this one, but it's okay, just estimate, okay. So you see the graph, the line of reflection go like this. So the point here, now I have to share the same 0 here, and the point here become x equal negative 1. I mark negative 1 here because this one equal 1 unit, right? I count 2 of them as 1 unit, and this one about 3 units, 1, 2, 3, 1.5 right here, okay. Oh, I'm sorry, right here. 1, 2, 3. So this point here, this point of inverse here is inverse of that point. Okay, let me move this one somewhere right here. So the point here is negative pi over 2 and negative 1. Now this point here becomes negative 1 and negative pi over 2. So then you grab the inverse like this. They share somewhere, they share this one, go like this. Okay, go like this. And you go like this. So they invert each other, okay, like this. So now this one is invert of sine invert here, okay, that is sine inverse. So now I'm going to cosine. Not mark again, this one 1, this one pi over 2, and this one pi. So the cosine is restrict between 1 pi over 2. Then this one restriction of cosine from here to here and from here to here. Okay, this one negative 1 and this one 1. Okay. Now, okay, if you go beyond, can be 1-to-1 function, right? So I put pi and negative 1. This point here. And this one equals 0. Now I do backwards. So pi over 2, 0 becomes 0 and pi over 2. The point here refers to that point right there. So this one pi and negative 1 become negative 1 and pi. Negative 1 and pi, you count negative 1 here, then pi over 2, 3, or this pi right here. So the point here is negative 1 and pi. Okay, so let's try to graph this one. So this one go like this and go like this. Okay, you see that the hold on, I missed one more. So this one 0 and 1, right, become 1 and 0 right here, 1 and 0 right here. So this one a cosine inverse right here. You see that? Okay, so you see clearly if I draw the line of reflection again. So what do I have here? I draw the line of reflection, so they mark somewhere right here, and the graph go like this. Okay, this point here reflect to that point, this point here reflect that point, and this point reflect to that point, and this point reflect to that point, for example, all the point reflect to the line y equal x. Can see that? So, so this on the graph of inverse of cosine, the graph inverse of cotangent and tangent, too easy, you take care yourself, okay? So now in the project I give you graph this one and this one the same graph, right? And you add up to see what you have, the answer. You have to do you have to guess what is this equal, okay? Okay, then you try to solve it, okay? So that's it.